Okay. Question about Big Bang Theory. This is relatively new in the syllabus, so always a good one for you to look at. As ever, try the question, look at it first, pause it, make sure you've done this one before you move on. Okay, it's always a good idea, although obviously listening to me talk about physics is 100% interesting. I think it's better to do it first and then go from there. Okay, so I'll assume you've done the question. We're starting off with a state question. Now, state the age of the universe according to Big Bang Theory. This is a bit controversial. I'm sure I've seen this as a 13.7. Okay, I'm sure I've even written this on my PowerPoint, so I'm starting to feel really bad about that. And the mark scheme says 13.8. Okay, this is one of these things that I wouldn't worry about. I think if you've written 13.7, don't get upset. Okay, this is, I think CI would be fine with it. However, on their mark schemes, they've gone for 13.8. Okay, and so therefore I would stick with that. We're talking about billion years. That's absolutely important. If you wrote million, then you would not get the marks. We then asked a question which I think is actually probably unfair because it implies an understanding of something which is well beyond our course. We're asked to state, so not explain, how the universe began, okay, according to this theory, the Big Bang Theory. What they're looking for is the idea, firstly, of the Big Bang involving the creation of the universe from a single point, okay, and the expansion from that single point. So what we have is a high energy, high density, high temperature, whatever you want, point called the singularity. You don't need that for your course, which then allows expansion from there. Okay. Again, I think 2 marks for that is quite. I think a lot of students would struggle with that. So we need the idea of a single point, expansion from that single point, and high energy, so high density on the mark scheme as well. Okay. We then got a nice question, which is a distance calculation and a time calculation. We're asked to find the shortest possible time for light to travel from Earth to Mars. How are we going to do that? Well, we're going to use our speed equals distance over time, or time equals distance over speed. And we need to know distances. Let's have a look over here. Well, we've got 2 distances. We've got a 5.6 times 10 to the 10, 4 times 10 to the 11. Well, if we want the shortest time, we want the shortest distance, we're going to use this one. We know the speed of light, and this is where it could be a bit tricky, where you may be getting 3 marks here, but they've actually gone for 2. It's light. We know the speed of light is 3 times 10 to the 8 meters per second. If this was a radio wave, if this was a microwave, if this is an ultraviolet, anything, it's always the same, 3 times 10 to the 8 meters per second. Notice it is not, I don't think you're told this anywhere in the question. If I'm wrong, my apologies. You just need to know the number. If you're not told the speed, then assume 3 times 10 to the 8, it's fine. You're going to divide that, and you're going to get 186.7, okay, 187, I think. Even in the mark scheme, you might have said 190. Again, if you've written 190, that's fine. It's 2 significant figures. Do not worry about that too much here. As long as they've seen that you're doing the right thing, that's enough. Okay. We then go from space to atomic physics, and we've got a couple of classics. If these come up, you'll be delighted. First one, we've got polonium being radioactive, and it decays by emitting an alpha particle. And we've got to complete the equation, folks. That's a nice one. Okay, we've got alpha, which has 4 and 2 on the top. We're going to remember that these numbers here are going to be adding up to make the top numbers here. So 210 equals 206 plus 4, that's right, okay. And then 82 plus 2 equals 84. This is all just about making sure your numbers add up. I had a little bit of an anxiety just at the beginning of that because I thought I'd said it was easy and then I made a mistake. I haven't, I think. So just check. That's all you have to do. Make sure those answers add up. Look at that, 2 marks versus this 2 marks. There is an inconsistency in these numbers. Although, not all questions are made equal, right? Not all marks are made equal. So even if you had trouble with that first one, you can definitely get some marks here. Again, classic question alert for the half-life. We are told the half-life, we're told mass. You can tell immediately what we're going to be asked here is what is the mass remaining after a certain number of half-lives. Okay, in this case, we're told 12.4 minutes. Look at that time, highlight the half-life, and wonder to yourself, why have they chosen 12.4 minutes? Well, it's because if the time is 12.4 minutes and the half-life is 3.1, we divide the numbers, we get a nice number, which is 4. Okay, I've noticed this in many of the papers, recent papers. They deliberately make the numbers a bit awkward just to mess with you, just to make sure that you're paying attention. 12.4 over 3.1 is 4 half-lives. So we've got an original mass m0, and all we're going to do is divide it by 2 4 times. Okay, 2, 2, 2, and 2. So that if I'm right, it divides by 16. You're going to do 560 over 16, which is 35. Now, I think this is amazing, folks. I've seen another question on another video that I've just recorded, which literally has the same answer. I'm just worried now. I'm getting my calculator out to check that I've not made a mistake there. I'm really anxious now. I'm going to divide by 2. 1, 2, 3, 4. No, we've got 35 again. They've even used the same answer. Now, obviously that's not helpful, but it's just interesting to see that the process and the answer are basically the same. Okay, half-life is different, but everything else is pretty consistent. I hope you're finding these half-life questions a little bit easier now.